In this part, we are going to discuss how pressure is measured. For that purpose, a device is used that is called as barometer. This is made up of mercury. The person who invented this, his name is Torricelli. So we are going to discuss what is now barometer. Now keep in mind, my drawing is not that good, but I will try to draw something. You have to understand it. And secondly, whatever diagrams I am drawing here, they are just schematic diagram. Schematic means for the purpose of study only I am showing. Don't ask me that how tube is standing automatically and all that. So let us start. First, you have to take a tube, which is hard glass tube. Why it is hard glass, I will explain. But right now we have to consider this is hard glass tube. Now this hard glass tube is having length of 1 meter. So you have to take that 1 meter. You are aware 1 meter means 100 centimeter. So here the tube is having length 1 meter, which is filled completely by an element. You are aware of this element. This is called as mercury. Latin name is hydrargyrum. Therefore symbol is Hg. Now this mercury we have to fill till top. In case of mercury, keep in mind there are two types of forces in liquid we are considering. One is called as cohesive forces and other is called as adhesive forces. Adhesive forces means molecules of that liquid is having affinity towards other molecule. Cohesive forces means affinity of same molecule with same molecule. So in case of mercury, cohesive forces are more than adhesive forces. Therefore mercury will come like this, bulging out. Like that mercury will be there. So this is now completely filled with mercury. Now we have to take another dish which is also filled with mercury, little bit. Now I want to invert this tube in this tube. So this way I will invert now tube and I will keep this tube as this way. Now initially I have filled this complete tube with mercury, but now I am making inverted tube. Now what is the expected thing? Because of gravity, all mercury should come down. Mercury is having very high density. Density means mass upon volume. So it is having density more than 13 gram per cc, cubic centimeter. So here mercury will, we are expecting that mercury should go down and a level here should get increased this way. But practical data shows that it is not happening to 100%. Mercury is going down, but to little bit extent. Say for example, if you are there at sea level, then we will find that mercury will be there something like this. And if you are marking here, this is approximately 76 centimeters. You are aware this total part is 100 centimeter. Out of that, this is 76 centimeter. Mercury is not falling down. Actually it should, but only this much of portion get vacated out. Whereas here it is there. The thing is that Earth is having tremendous gravitational force. Because of that, Earth is pulling out atmosphere. Atmosphere means gases. They are pulled towards Earth. As a result, the pressure is there, that is called as atmospheric pressure. So here we are getting atmospheric pressure over here. Because of that pressure, mercury is not able to fall down. Little bit it will fall and then equilibrium will establish. Suppose I am going in higher altitude. Sea level is there. Apart from sea level, I will go to higher altitude. Then the thing is that atmospheric pressure will start decreasing out. As a result, if this pressure is decreased, then downward movement is possible, and this way mercury level will start falling down. So for approximately every 160 meter altitude. Real number is 165 meter, but for general purpose, for calculation purpose, we are considering this as 160 meter. So for 160 meter altitude, mercury level will fall by 1 mm, 1 millimeter. So here if I am considering this as 760 I should consider this as 760 millimeter. So suppose I am at sea level, it should be 760 mm of mercury. But when I will go 160 meter higher altitude, the level of mercury will fall by 1 mm. Suppose I am going 1600 meter altitude, level of mercury will fall by 10 millimeter. So like that, atmospheric pressure will decrease. So this way, this is the height of mercury column that is measured, and we can measure atmospheric pressure over here. Instrument is called as barometer. The instrument is designed by a person named as Torricelli, and then he told that whatever the thing here, this is vacuum. Why? Because mercury is going down, but mercury is a dense metal. It is in liquid state but metal, very dense metal. As a result, when it is going down, it is not displacing out air. If air is displaced, then barometer will not work. So there is a vacuum. This vacuum is named as Torricelli's vacuum. So here we are getting practically creation of vacuum. No doubt it is not up to 100%, but very great vacuum is produced over here, that is called as Torricelli's vacuum. Now, if you are increasing pressure here, then automatically mercury will rise. So if you are taking this instrument and going under the soil, then obviously under the soil means we have to make tunnel and go downwards. Particularly you are aware of mines and all that. So if you are going to mines, then you will get idea that pressure is increasing out. So this way we can measure pressure, that is in terms of millimeter of mercury. So we are considering 760 mm of mercury. Pressure is written this way, 760 mm of mercury, that is considered as 1 atmospheric pressure. You are aware that as we are going to higher the altitude, pressure will decrease. That's why lot of changes occur. But right now we are just considering here barometer and how pressure is calculated here. So on barometer we are getting pressure in terms of 760 mm of mercury.